Your dog is asleep at the edge of the room. The house is quiet, nothing is happening. Then one paw starts moving, not randomly, rhythmically, like it is running. Its nose twitches, its breathing changes. Maybe it makes a small sound, not quite a bark, not quite a whimper, just something from deep inside sleep. And everyone thinks the same thing. It is dreaming. But how would we know? A dog cannot wake up and tell you it was chasing something. A cat cannot describe what it saw in the dark. A bird cannot explain that it heard music while it slept. Dreams are private, even in humans. The only reason we know you dream is because you wake up and report back. Animals never report back. So scientists had to ask a different question. Not what did the animal dream, but did the sleeping brain behave like it was somewhere else? And that question led to rats. At MIT, researchers trained rats to run around a track for a food reward. While the rats moved, scientists recorded activity in the hippocampus, the part of the brain involved in memory and navigation. As each rat moved to the track, its brain produced a specific pattern, almost like a map, a neural signature of that route. Then the rats went to sleep. During REM sleep, the stage strongly associated with vivid dreams in humans, those same patterns appeared again, not vaguely, not randomly. The sleeping brain replayed activity linked to the maze. The match was so close that researchers could estimate where the rat would be on the track if it were awake. Think about that. A rat that spent the day running a maze may have its brain replay that route at night, even while its body is completely still. No track, no food, no movement. Just the memory map lighting up again in the dark. And it gets stranger. In another study, researchers found replay during slow-wave sleep too, but this replay was compressed. A path that took seconds while the rat was awake could return in a burst lasting only a fraction of a second. The brain seemed to cut the day into pieces and run them back through the system. That does not prove the rat saw a dream the way you see a dream, but it proves something important. Sleep was not empty. The animal's brain was processing a life it had already lived. Birds make the case harder to dismiss. Zebra finches learn songs, and for a male zebra finch, song is not just sound, it is identity, courtship, communication, survival. Researchers recorded neurons involved in singing while the birds were awake. Then they recorded those same neurons while the birds slept. The bird was silent. Its beak was not performing the song. Nothing in the room was singing, but inside the sleeping brain, the song pattern returned. So if a zebra finch dreams, its dream may not look like a human movie. It may be closer to a silent rehearsal of song, not necessarily a story, not necessarily a picture. A sleeping brain replaying the pattern of a song without making a sound. Cats gave science one of the most unsettling windows into this. Normally during REM sleep, the body is mostly paralyzed. That paralysis is the reason your sleeping body does not act out every movement in your dreams. In the 1960s, sleep researcher Michel Jouvet studied what happened when that paralysis system was disrupted in cats. The cats were asleep, but their bodies began performing organized behaviors, not just twitching. They moved in ways that looked like stalking, defending, attacking, exploring. The body looked as if it was responding to a world that was not in the room. That matters because twitching is easy to explain. A random paw movement does not prove much. But coordinated behavior is different. It suggests the sleeping brain may be generating some kind of internal scene, or at least some kind of internal action pattern. And then there are dogs. Dogs are harder because we do not have the same maze replay evidence in dogs that we have in rats. But dogs do show recognizable sleep stages, including non-REM and REM sleep, and dog sleep changes with experience. Studies have found that after learning commands, dogs show changes in sleep activity. Their sleep is connected with memory performance. After a more active day, dogs tend to sleep more and spend more time in both non-REM and REM sleep. That matters because it means a dog's sleep is shaped by its waking life. The walk, the training, the stranger at the door, the person who came home, the smell on the sidewalk, the moment you said its name. If dogs dream, the content would likely be shaped by the way dogs experience life, scent, motion, pressure, attachment, fear, play, and familiar people. A dog probably does not dream in words. Maybe when its paws move, the sleeping brain is replaying pieces of a world built less from language and more from smell, movement, and memory. But mammals are not the end of this. Octopuses make the question much stranger. An octopus has no backbone. Much of its nervous system is distributed through its arms. Its brain is so different from ours that researchers often describe octopus intelligence as almost alien. And yet, But octopuses appear to move between distinct sleep-like states. There is quiet sleep. Then there is active sleep. During active sleep, octopuses can change color and skin pattern. Sometimes those patterns resemble the ones they use while awake. Their bodies briefly return to something wake-like while the animal is still asleep. That does not prove an octopus is dreaming of hunting crab, but when its sleeping brain and skin briefly return to wake-like patterns, the possibility of dream-like sleep becomes harder to dismiss. Because if something like dreaming exists in an octopus, then dreaming is not just a mammal thing. It is not just a dog thing. It is not even a backbone thing. It may be something nervous systems discover when the outside world turns off, and the circle keeps widening. Researchers studying baby jumping spiders found repeated bouts of retinal movement during rest, along with leg twitching and curled postures. Not proven dreaming, but something surprisingly close to the sleep patterns we associate with it. Bearded dragons show sleep patterns resembling REM and slow-wave sleep. Zebrafish show sleep signatures with similarities to slow-wave and REM-like sleep. That is where the story starts to feel ancient. The sleep states connected to dreaming in humans may be older than dogs, older than mammals, possibly older than the first animals that ever looked anything like us. So why would evolution keep this? Sleep is dangerous. A sleeping animal cannot hunt. It cannot mate. It cannot watch for predators. It cannot protect itself the same way it can when it is awake. If sleep survived across so many species, it is probably doing something essential. One possibility is memory. Sleep may help animals sort what mattered, strengthen maps, rehearse skills, process threats, prepare the brain for tomorrow. A rat replays the maze. A bird replays the song. A dog's sleep changes after learning. An octopus flashes through wake-like patterns in the dark. Across different bodies, different brains, and different worlds, sleep keeps looking less like shutdown and more like internal processing. But here is where the clean answer breaks. A replay is not automatically a dream. REM sleep is not automatically a dream. Twitching is not automatically a dream. Even in humans, dreaming can happen outside REM sleep, and REM sleep can happen without a remembered dream. In humans, the final proof is always the same. Someone wakes up and says, "I was somewhere else." Animals never say that. So the honest answer is not that we know animals dream the way humans do. We do not. We can record the maze lighting up again in a rat's brain. We can watch the sleeping bird's song system replay its music. We can see a cat move as if it is hunting something invisible. We can watch an octopus change colors in the dark. We can measure the patterns. We can track the behavior. We can compare the sleep states. What we cannot measure is the inside. Maybe your dog is chasing something. Maybe it is remembering. Maybe it is rehearsing. Maybe there is no story at all. Only fragments of smell and motion passing through a sleeping brain. But the more closely science looks, the less sleep looks like nothing. It looks like another kind of waking, sealed off from the outside world. And maybe that is what a dream is at its deepest level. Not a human movie behind the eyes, but a mind returning to the world after the body has gone still. A rat runs without moving. A bird sings without sound. A cat hunts without prey. An octopus changes color for an ocean that is not there. And beside your bed, your dog's paws move softly in the dark. We may never know whether it went anywhere at all, but something in that sleeping brain was not empty.